let's have a look at this lab. So we'll have a look at some basic hashing methods. So the first thing we're going to do is to look at some hashes. So we'll just use the website just now and see if we can pick off our hash values. So we have some data of Falkirk. So we can actually see that that's that value there. Okay, so this is Falkirk. So the next one we'll try is Edinburgh. So remember the case of the letters actually matters. So we'll just try Edinburgh. And Edinburgh starts with 03C. So that one must be Edinburgh. So we'll try Glasgow now. I'll do that one. And Glasgow starts with a D5. So this one here is Glasgow. And then the last one, hopefully, is Stirling. So we'll just try that one. Just to make sure that we have them all there. And remember, the invisible characters like new lines and spaces make a difference. So it's EE. And there it's there. Okay, so that one's Stirling. So now what I'll do is we'll use the MD5 SSL OpenSSL application with MD5 to be able to see if we can actually find our hashed values. Okay, so I'm just using Kali instance here. So we'll just get logged in. And there we go. So let's just get logged in there. There we are. Okay, so let's see if we can get this over there. And hopefully we can use the two together on the screen. Okay, let's see if I can just increase the font size there. Make it easier for you to see. It's a bit better. Okay, so we just echo minus n, and we'll try Falkirk, and then we'll pipe that. So sometimes we've got to find out where the pipe is. So OpenSSL for MD5. And then we go there. Okay, so we can see that one is this one here. We'll try one more. And then for this one, so we've got to try Edinburgh. There we go, 03. That's that one there. Okay, and the number of characters that we have within our base 64, within our hexadecimal MD5 signature, it's 128 bits. So if we divide that by 4, we get 32. So there should be 32 characters in there. For our SHA-1, it's 160, so just divide 160 by 4, and you should get the answer there. Okay, so the next thing that we're going to do, we're actually going to have a look at an example shadow file, which is the password file that you would see in Linux. So what we do is we pick off, that's the algorithm, which is APR1. So we run OpenSSL, and we want the password method, APR1, and we pick off the salt. So the salt is contained in here. So hopefully you should find that you can copy and paste from your into your virtual machine. Okay, so let's copy and see if we can paste. Good. Okay, so that's our salt, and then what we'll do is we'll try each of the passwords. So the passwords that we've been set are here. So we have password, Napier, Inkwell, and Anchor123. So we'll just try password. Okay, so it's not password. It ends with an M1. So now let's try Napier, and that's it. Okay, so Bill's password is Napier. Let's do the next one. So let's see Mike. So Mike's salt is this value here. Again, we'll just copy that one, bring a row command up, and put in our salt. Just paste it in there. Okay, so let's go through the same thing. Password. Nope, we're looking for a Q0 at the end. Napier. Nope. Inkwell. Nope. Hopefully it's going to be Anchor123. And it is. Okay, so Mike's password is Anchor123. So next we'll try Fred. From there's Fred's salt. Okay, there we go. Just pick that off. And I just fire it in here. Okay, so this is Fred's password. Okay, so password. It's not that one. We're looking for an S0 at the end. It's not that one. That's it. So Fred's password is Inkwell. So we'll do the last one, and you see the last one actually has a different method. So OpenSSL supports APR1, and if we have a 1 here, it's MD5. So in the very last one, we've got to change it to a -1 there, and then we'll put our salt in there, and there's our salt, and we'll just pick that off there, and then we'll just paste that in there. Oops. Okay, we'll just paste it in this time. So I'm obviously not getting it right there. Okay, so just copy over here, and then I'm going to paste. Perfect. Okay, so now I try password, and I try Napier, and that's it. Okay, so it's an MD5 salted hash there. Remember what we do with salted passwords. We'll take the one method is we'll take the password, we'll hash it, we then add the salt on, and then we hash it again. So it's impossible, well, it's very difficult to know what the we'll get a different value for each different values of salt. Okay, so now what we'll do is that we'll just download these files. Okay, so let me just copy them, and we'll do it in Kali. Okay, so we can use MD5 to be able to find out if a file has been changed or not. So what we'll do is we'll just download these files, and I'm just going to extract them to the root folder, and then we'll have a look at them there. Okay, so just there they are, 1, 2, 3, and 4. Okay, so what we would do is open SSL MD5 1.txt. That one hasn't been changed. Okay, so let's have a look at the next one. That one has been changed, okay? Because you can see the hash value here is this, and then we get this, so that file has been changed. Next one, we're looking for a 1 at the end. That one hasn't been changed. And then for the next one, that one hasn't been changed, okay? So only one of the files that we found has actually been changed since we took the thumbprint for it. So now what we'll do is we'll just download this file here, and we'll just copy the hypertext link. So in this one we'll actually show that sometimes we get what's called a collision, and a collision is can happen when we have two different documents in this case, and they lead to the same hash signature. Okay, so we'll just open that one up, and there are PostScript files, and again we'll just extract them to the root folder. There they are. Okay, letter of rec there, and order.ps. If you want to have a look at them, let's see if we can view the contents. Okay, here we go. Okay, so there's one of them there. Okay, so there's the letter from Julius Caesar, and the other one is from Julius Caesar, but actually it has some secret information in it. Okay, so you can see they're actually different, but when we take the MD5 hash off them, let's have a look. So open SSL, MD5, and the file is called letter of rec. Okay, we get 49 at the end, and then the other one I think was called order. And there we go. Okay, so you can actually see that gives us the same hash, even though we have two different letters there. Okay, then for the next part, we have two different executable files which do two different things, and we get the same hash signature. Okay, so let's bring up our browser again. Just open them up, and then we'll just extract them to the root folder again. Okay, so the file was named arrays and hello. Okay, so to make it executable, we'll do the +X to make it executable, and arrays, change mod +X, and the other one was called hello. Okay, so there they are. We have our two files now, so let's run them. So it looks like we're having problems running these executables on our Kali instance. If we look at the file type, it should be executable, but it's just not running. Okay, but what we should be able to prove is that we can do an MD5 on our two files, and we get the same hash signature. Okay, so for the next part, what we'll do is we'll use hashcat. Hashcat can either be compiled for Intel type architecture or for CUDA. In this case, we're just using the standard PC. So hopefully the version in here is our Intel version. So the first thing we'll do is we'll set up our words file. Okay, so these aren't our words. Okay, these are our hashes. So we'll set up our words file. So our words that we've got are Napier, password, ankle 123, and ink well. And then we'll create our hash file. Okay, there they are. Start them there. There we are. Okay, so we'll use hashcat -m 0md5 hash2 and words2. So what should happen is that hashcat will go into the words file, pick off the words, make a hash, MD5 hash, and then compare it with the hashes in hash2. Okay, there you go. Wasn't that easy? Took less than a second. And the first one is Napier, second one is password, ankle 123, and inkwell. Okay. Is that in this part the hashes are all names of fruits. Okay, so we'll just set up a word file for that. Okay, so let's think of a few fruits: apple, orange, coconut, peach, pear, kiwi, and melon. Okay, that's called the words2. So what we'll do is we'll open up a file called hash2. Okay, and we'll just get rid of all of that. And we'll just paste in our hash codes, and let's see if we can get them all. So if you're doing it, then you can get a list of well-known fruits and just paste them in. Okay, there we go. That's our hash codes. Okay, so what we want to do is to be able to run our hashcat again. So hashcat -m md5, so hash2 and words2. There we go. Found 4 of them. Okay, so you have to find the other one. Okay, so now what we'll do is we'll use John the Ripper to be able to read the LM hash. Okay, so this time we have an NTLM hash, so we'll be using that as a method. So let's copy that there, and I'll just put it straight back into the same file that I created before. Okay, we'll just paste that in, and then we're good to go. So that's our hashes, and then we'll get our words up. And what these are, oh, the fruits. So I shouldn't have, I just exit there again. Good to see. I just exit. See, we've got our words. That's fine. Okay, so we're going to use John the Ripper. So with John the Ripper, then we've got some arguments. So format, we're using NTLM format to be able to crack the second part of it there. And then there is our word list equals file. Okay, so John minus our word list, I think was called words2, and then our format was equal to NT, and then I think we called it hash2. There you go. So Bert's password is orange and Fred's password is apple, which is correct. Okay, so this is easy. So now let's try the next one to see how we get on. Okay, so we'll just use the same file as before, and we want our hash there. No, we want our hash file. And let's get rid of that. Put in our new hash values. And now it's Scottish cities, so let's go for words and Edinburgh, Glasgow, Dundee, Aberdeen, Perth, Stirling. Give these a try. Okay, so that's called words2. So we should be able to just use the same command that we used before. And there we go. So admin is Dundee, Fred is Aberdeen, and Perth is Bert. Okay, so let's try this one. It's the names of animals. Copy. And so this time again we go through it again. Nano words. So this is our hash. What are we doing? Okay, so we have to think up some names of animals. Okay, we just check that that's right. Yeah, that looks good. Oops. Okay, used the wrong file name there. Nano words2. Okay, so let's think of some animals. Dog, tiger, fish, elephant. Okay, so just think of some animals that you can think of. Hopefully we'll be able to pick off one from there. That's a word. So here we go. Okay, I got tiger, which wasn't too bad. Okay, so if you do the same, then hopefully you should be able to get them cracked. Okay, so what we'll do is we'll do the same again, but this time we'll use offcrack. So offcrack we get from our applications. Offcrack has a GUI associated with it. Okay, so we have some tables, and I've downloaded these tables here, which should crack most hash passwords. And then we'll just load up. From here. Okay, so I think we put in hash 2. Okay, this was the last one. So snake. Okay, it'll take you a bit more research to be able to look at the admin one, but see how you get on.